Welcome to this session. In this session, you are going to solve a problem on determination of inverse of a square matrix by elementary transformations or elementary operations, or sometimes the method is called Gauss-Jordan method. Now, what you do, you rewrite the matrix in the form A I. So you may separate this by a straight line or a dotted line. Dotted straight line or just normal straight line. And then the thing is that you use row operations so that this side where this A changes into an identity matrix, and this other side will have a matrix P. So the inverse of the matrix is this P. So let's do that. So solution. So we have A, I. I remember I should have the same order as A. So it'll be given by the matrix 3 minus 3, 4, 2 minus 3, 4, 0 minus 1, 1. And then you separate A by a straight line. Then write the identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. Now this is the identity matrix that we write. Assuming A was a 4 by 4 matrix, then you write a 4 by 4 identity matrix. If A is a 2 by 2, then also I will be a 2 by 2 matrix. If A is an n by n, then I should also be n by n. So now, because the objective is to ensure that this position of A changes into identity, then we expect to have 1, 0, 0, 0, 1, 0, 0, 0, 1 in this position of A. But you see, this is not 1. So we'll have to make this one 1 by saying row 1 to be 1 over 3 of that row 1. Then you can say, let's keep row 2, let's keep row 3. It's usually advised to do one step at a time so that you don't make mistake. So row 1, row 2 is row 2, row 3 is row 3. So we are trying to ensure that we have 1 in this position. So that will give us that will be equivalent to 1 and then negative 1, 4 over 3. Please don't put decimals here. Say 4 divided by 3, you write 1.33. If you put decimals, then there's a high chance you'll make some mistake or round of errors, and that will introduce errors in your calculation. So it is always advisable, once you are doing these calculations, let all your values remain in fractions. Only involve decimals when it is impossible to write that value as a fraction. Fraction gives exact values. So this a third, 0, 0, and this is 2 minus 3, 4, 0, 1, 0, 0, minus 1, 1, 0, 0, 1. That is step 1. So at least we have this. But this position must be 0, but though we are saying a 2. So what we do, let's also correct this one here. So we say row 1 to be row 1, row 2 to be row 2 plus negative 2 row 1. Because when I add -2 to 2, I get 0. So I have corrected that position. Since this is 0, let's keep row 3 to be 0 in this step. So by that, we'll have our new transformation will be 1 minus 1, 4/3, a third, 0, 0, and then we have 0 now. So -3 plus -2 times -1. That will give us -1. And then 4 plus -2 times 4/3. That will give us positive 4/3. And then 0 plus -2 times 1/3, we get -2/3. And then 1 plus -2 times 0 is 1. 0 plus -2 times 0 is 0. This is 0 minus 1, 1, 0, 0, 1. So that is that step. So we have achieved 0, 0. But remember, this should be 1. So I'll correct it by multiplying everything by -1 in this second row. So I say row 1 to be just row 1, row 2 to be -1 times the current row 2, and then row 3, let me keep it just to be row 3. It's always good to do one step at a time to avoid mistakes or errors in the calculations. So that will give us 1 minus 1, 4/3, separated by this line, a third, 0, 0, and then 0. Now this will be 1. Now minus 4/3, and then positive 2/3. Now this becomes -0. This is 0, -1, 1, 0, 0, 1. Good. So this is from that step to that step. Now we also expect this position to be 0. So I'll say, let me keep row 1, and let me keep row 2 because I've done it in the previous step. But row 3, I'll use row 2 to correct it. I'll say it to be row 3 plus. Now, when I multiply 1 by row 2, and then I add the 2 rows, I'll get 0 at this position. So that calculation will enable me to get a 0 here. So I'll get 1 minus 1, 4/3, a third, 0, 0. This will be 0, 1 minus 4/3, 2/3, -1, 0. So 0 plus 1 times 0 is just 0. Adding these two, we get 0. And then 1 plus -4/3 will give me -1/3. And then this, when we add, we get 2/3. This will be -1. This is 1. So that's what we have. And remember, I expect this position to be 1. So I'll say row 1 to be row 1, row 2 to be row 2, but then row 3, I'll say -3 times current row 3, so that negative 3 times negative a third, I get positive 1. So that will give me, I'll get 1 minus 1, 4 over 3, a third, 0, 0, 0, 1 minus 4 over 3, 2 over 3, negative 1, 0, 0, 0, 1. Now that's negative, negative 2, and then positive 3, negative 3. So that's what we have. Now I expect to have 0 here, 0 in this position, 0 in this position, 0 in this position. So the first thing I'll use row 3 to correct this position and this position. So I say row 1 to be now reciprocal of this. So I'll have, this is what I ask myself. I have 4 over 3. What should I multiply by 1 so that I get 0? So it's like 4 over 3. So if I say this is x, so this is negative, or this is the x. So when I say row 1 plus minus 4 over 3, row 3, then I'm assured of getting 0 in this position. Similarly for row 2, I'll say row 2 plus, because this minus now, the sign will be plus 4 over 3, and then row 3, and then I say row 3 to be just row 3. So by doing that, I'll get an equivalent matrix. So this is 0, so just have 1. This is 0, this just be negative 1. And then this will be 0. Now I have 1 over 3 plus minus 4 over 3 times the value here is minus 2. That will give me positive 3. And then 0 plus minus 4 over 3 times 3. I get minus 4. And then this is 0 plus minus 4 over 3 multiplied by minus 3. So that would give me positive 4. So that's the first row. And then here I have 0, 1, and then this will be 0. So here I have 2 over 3, and then plus 4 over 3. Remember, this now is positive, multiplied by this negative 2. That will give me minus 2. And negative 1 plus 4 over 3 multiplied by 3. That will give me positive 3. And 0 plus 4 over 3 times negative 3. That will give me minus 4. Now this one is 0, 0, 1, minus 2, 3, minus 3, because row 3 was not interfered with. Now remember, so this isn't correct order. This should be 0, this should be 0. So the only problem with this element here, but can always be corrected by simply saying this negative 1 plus 1 gets 0 here. So I say row 1 to be row 1 plus row 2, and then row 2 is in the correct form. Row 3 is in the correct form. So this will be transformed into 1 plus 0 is 1, minus 1 plus 1 is 0, 0 plus 0 is 0, 3 plus minus 2 is 1, minus 4 plus 3 is minus 1, 4 plus minus 4 is 0, and then this is 0, 1, 0, minus 2, 3, minus 4, 0, 0, 1, minus 2, 3, minus 3. So you see this on the left-hand side now, in this final step, this is an identity matrix. And so this is what we are calling P. So this implies that A inverse is the same as P, which is the same as the matrix 1 minus 2 minus 2 minus 1, 3, 3, 0, minus 4, minus 3. So that is how we solve that problem on how to find inverse by row or elementary row operations. So that is solution. Thank you.